Good morning. In today's lesson, we're going to talk about adding and subtracting rational expressions. Now, something we should know about adding and subtracting rational numbers or rational expressions, that anytime we are performing that type of operation, we need to have a common denominator. Now, in previous lessons, we talked about multiplying rational expressions, where we broke everything down, factored everything as much as we could, and then we would cancel things out to make it easier. This is a little bit different than that. We will still be factoring things down in the more complex problems to see what is needed on both sides of the equation. But today we're all about finding common denominators. So starting off in our vocab, in the expression a over b, if a and b are integers and b cannot be equal to 0, then a over b is a rational number. All right, then moving along. If we are going to add those fractions, 2 over 7 plus 4 over 5, just like I said, these are both rational numbers, so we are going to need to come up with a common denominator. Now the least common denominator between 7 and 5 would be 35. So the way that we would do that on this left-hand side is multiply by 5 over 5. And the reason why we do that is really just multiplying by 1. We know that 5 over 5 is a 1, and anything times 1 is just itself. So when we multiply by 1 or 5 over 5, we're just multiplying by 1 in a smart way. We know that we need to multiply that other side by 7 over 7, doing that same concept. Now we will get 10 over 35 plus 28 over, what am I doing? Over 35. So if we add those two things together, we get 38 over 35, and we could simplify that down to 1 and 3/35 if we wanted a mixed number. And then for this last one, if we're going to factor this expression, 12x squared minus 28x plus 15, one thing to note is that we have a minus here, but we have a plus out here. Because we're multiplying to get that 15, I know that my last two factors are going to be negative, because when I add them together, when being multiplied by some factors of 12, I have to come up with negative 28, but when I multiply them, I get a positive number. So when I'm factoring this down, these are always a little bit like a puzzle. So I know that those factors are negative 3 and negative 5. Now, that 12x, I have a couple of options, but that negative, they have to add up to get that to that negative 28. So it could either be like 6x and 2x, or it could be like 4x and 3x. So I want to think of numbers that I could possibly get to that negative 28. So you might have to try more than one thing, and that's okay. What I would ask is that if you try something and don't get it right, don't just give up. Try something else. But I know that 6 times negative 3 will get me negative 18. Now, if I chose 6x for that factor, then over here that has to be a 2x, and that gives me a negative 10x. So those two things added together for my outside and inside, if I was going to FOIL this back together, I would get that negative 10x minus 18x, which gives me that negative 28x that we're interested in. So those would be our factored terms. All right. Now going into some new material, both rational numbers and rational expressions are expressed as ratios. A rational number, just like we talked about in our warm-up, a over b, for integers a and b where b can't be equal to 0. A rational expression, we have two functions. So we have f of x over g of x. For the polynomials f of x and g of x can't be equal to 0, just like if it was a number. And then the degree of g of x has to be greater than or equal to 1. Again, that degree is the same type of concept as that 0 in the denominator. Recall that a rational expression is undefined for values of the value that cause the denominator to equal 0. In this lesson, assume that all rational expressions are defined unless otherwise indicated. So in this lesson, we will talk about a couple of those cases where we need to figure out what our undefined values would be. So to start off, very easy example to start off with, we need common denominators and we already have them. So if we have 1 over 2x plus 3 over 2x, we can add those together because we already have common denominators. Now for this, since we have a 4 and a 2, we can simplify this down to 2 over x. And if it was asking about what values would x not be able to be, x could not be equal to 0 in this case. Moving on, a little bit trickier, but still we have the same denominator, so we can subtract these right off the bat. So the way that would look for a bigger piece or a bigger rational expression like this is we can just rewrite that as x minus 1 over x squared minus 2x plus 1. Now, what would happen if we were going to simplify? We wouldn't just have what we have right here. So we can factor that denominator down to x minus 1 and another x minus 1. So on top we have an x minus 1. On the bottom we have x minus 1 times x minus 1. So this top piece would cancel out with one of those on the bottom so that we have 1 over x minus 1. And again, we would say x cannot be equal to 1 because if I plugged in a 1 for x, we would get a 0 in the denominator. The next piece, find the least common denominator for these two rational expressions. So on the left-hand side, we have a 1 over 2x. On the right-hand side, we have a 1 over 7x. Now, they both have x's, so I don't have to worry about that. All I'm concerned about is numbers, since they both share an x. So we think of the least common denominator, and we would have 7, and we would have 2 over here, because that's the pieces that those denominators are missing. You'll see a little bit more of what this looks like when we have more complex scenarios. But this is what our two rational expressions would look like if we found those like denominators. And then again, if I have 1 over x squared minus 4, and then I have 1 over x squared plus 5x plus 6, remember that this over here is a difference of squares. So this can be rewritten as 1 over x minus 2 times x plus 2. And this right-hand side can be, let's see, x plus 2, and then x plus 3. Now, we just have to look at the left-hand side and the right-hand side and say, okay, we have these in common, but my left-hand side is missing an x plus 3. So again, we have to multiply that by the top and the bottom. And the left-hand side is missing an x plus, or an x minus 2. So now on the right-hand side, they might not be in order, but we have an x plus 3, an x minus 2, and an x plus 2. On the right-hand side, we have an x plus 2, an x plus 3, and an x minus 2. So everything is the same. I'm not going to make you FOIL all this out again. Just realize that those are the things that we're missing. If you multiply one side by something, remember you have to multiply the top and the bottom by that same term. All right, so like I said, we would have to figure out undefined values. Um, so we're going to factor this denominator down. The first thing to realize is that we could take a 2 out of that denominator. So we have x squared plus 2x minus 3. And that makes it a little bit easier for us because we have 1 over 2, and now it would be, it looks like that would be an x minus 1 and an x plus 3. So then those undefined values would be what x value could I plug in, or what value could I plug in for x to get a 0. So in this case, we have 2 of them. X can't be equal to 1, because if I plugged a 1 into that x minus 1, that would give me a 0 and would cancel everything out. And x can also not be negative 3. All right. Now, even though they're both monomials, we just have to look at what are we missing. So on the left-hand side, if I would want that to be a 6, I need to multiply by a 2 over 2. Now on the right-hand side, notice the left-hand side has x cubed, whereas the right-hand side has x squared. Now if I'm adding these, again, remember we need common denominators, and if we multiply those, we have to multiply the top and the bottom. So now we would have 2 times 1 is just 2 over 6x cubed plus 1 times x is just x over 6x cubed. And we could simplify this down to 2 plus x over 6x cubed. Okay? I'm going to leave this one for you. It's the same kind of concept. You just have to say, what are we missing after you have already factored those denominators down. Okay, our last one. We are talking about a round trip, time travel, or travel time. On a round trip by car, it took 2 hours longer on the return trip than it did on the first leg of the trip. How much faster did the car go on that first part of the trip? So something to realize is that speed is distance over time. So that first part of the trip is just distance over time. And then we know on the return trip, we have distance over time plus 2. Now the reason why it's plus 2 is because it took 2 hours longer on that return trip. Now that plus 2, I'm going to put that in a binomial type of parameter. I'm going to put parentheses around it. So what I'm missing on the left-hand side is a t plus 2. So remember, I have to multiply the top and bottom by that. And the right-hand side just by a t. So we would distribute. We have a dt plus 2d minus a dt all over t squared plus 2t if I distributed those denominators and combined them. Those two things would cancel out because we have a positive and a negative. So 2d over t squared plus 2t would be the speed, or how much faster it took for the trip on the way there. All right, here are your homework problems. If you have any questions, feel free to email me, or you can leave a message on Schoology. I hope you guys have a great day.